Hello, hi Conf42.
Hi, thank you so much for coming.
It's so great to be here. It's like our second Conf42.
Yeah, it's a second.
Second of 42, I guess. I don't know. Yeah, so thank you very much for coming. I'm Shimon.
I'm Noah.
And yeah, let's get straight to it. So, what are we going to talk about today?
Today we're going to talk about centralized policy management at scale.
Tam tam.
But first, let's talk about us. So, my name is Noaa Barki. I'm a full stack developer. I'm a tech writer and also one of the leaders of GitHub Israel community, which is the largest GitHub community in the whole universe.
Amazing. And my name is Shimon. I'm one of the co founders and the CEO of Datree. I'm an AWS community hero, and I live and breathe DevOps and infrastructure. And this is why we're here. So, today we're going to talk about how to manage centralized policy at scale. And we're going to show it to you in the eyes of a Kubernetes administrator that tries to manage the policies for the organization. But I think it can be applied not only for Kubernetes, if you're a serverless organization or
Yeah.
any other organization. So, what we do in the tree is we see a lot of organizations that deal with policies because we help prevent misconfigurations um, from reaching production. And this is what we do. And policies is how we roll. And we have an open source CLI that runs policies. And we just passed 5,000 GitHub stars.
Yeah, woohoo!
Yeah, so we're really, really happy, but let's get into it. So today we want to talk about how to avoid this.
Misconfigurations. Yeah, and I really like to say that as a developer at Datree, what I do, like we do policies for a living, but what I do is not only to understand about Kubernetes, how it works, and what are the policies that we want. It's also to understand how you can blow up your own cluster. So I really understand why organization needs the centralized policies, and this is what we are going to talk today. And the real question, the main question is how you can prevent the next misconfiguration, the next production outage. And after a lot of thinking, 100 postmortems, if you saw that talk, we summed it up into three major steps. So step number one, or step number zero, actually, the first step.
How many fingers does a developer have? 4. 0, 1, 2, 3.
So the first step is meet OPA. OPA, it's your policy engine. OPA is a general purpose policy engine. It gives services the ability to decouple decision-making logic from policy enforcement. You can basically think about OPA like a super engine. You can write your policies into it. You can publish your policies into it. So whenever you execute it, with every input, JSON input, OPA will checks if it violates any one of your policies that you published.
You can talk to it using API or using or importing it as a library, and it will evaluate the business logic of whether it should allow a policy to pass or not.
Yeah.
And there are many different use cases, not just to check for configuration. There are many authorization use cases that are being used with OPA and the other things.
Yeah. But the real beauty of OPA, the real magic behind OPA is that OPA enables you to offload and unify all your decision making logic into a dedicated server.
Yeah, so you can decouple your business logic from your application logic, from your decision making of whether a user can perform an action of delete, let's say. So you offload it to a different service that does all of this calculation, and then you don't need to build this logic of policies inside every one of your microservices.
Yeah. And this is really empowers admins in the organization to have control over their system.
Yep. So moving forward, by the way, I'll just say that OPA is part of the CNCF Foundation. It is a graduated project. We really, really recommend doing that and using it.
Yeah. So to use OPA, it's very simple. First, you need to integrate with OPA, and you can use OPA as an embedded package inside your project if you're using the Golang language, or as a host daemon. You write your policies in Rego language, we'll talk about later, and you query OPA by sending an HTTP request with the input, and OPA will do the rest.
Or you can call it as a library and then
Yeah,
just
yeah,
just call it directly.
yeah. And this is an example of the Rego language. It's a declarative language. It's very easy to learn. From experience, I'll tell you that. And this is an example of a policy written in ORBA, which violates if deployment resource have the app label. And it's very straightforward. You can mark my word.
Yeah, it's a nice declarative language, and there aren't many loops and stuff like that. It's like what you see is what you get. This is, I guess, what they
It's
tried to do.
yeah, it's more like SQL than
That's a good
JavaScript. I
comparison.
always like to say,
Yeah.
yeah. But let's move forward to step number one, which is define your policies.
Cool. So defining the policies is very important. So I remember when I was an engineering manager for 400 developers, and one developer made a mistake and it propagated to production and we had an outage, and it's okay, it happens. I also make mistakes all the time. But I thought to myself, like, what can we do? How can we prevent the next outage? And for me, we tried sending emails and stuff like that, which obviously doesn't work. So we said, okay, we need some sort of framework, some sort of guardrails, so everyone will work by them. And we call them policies. And number one, you need to define what are your policies. For example, make sure that every Kubernetes workload has a memory limit and CPU limit and has a liveness probe and readiness probe, and every Docker container has a health check. So that's a policy. And now you want all of your microservices to follow this policy. So number one, define the policy. Let's say all workloads should have memory limits. And number two, define a granular policy. So just having a top level thing that tries to narrow everything down, I don't think it's good enough, because let's say you put a 4 GB memory limit, but then you have a AI workload that needs 50 gigabytes. So start from the top as broad policies and then go deeper and deeper to more granular policies.
Amazing. So now that you have defined the policies in your organization and you know what you want to enforce, the real question is how you integrate the policies inside your pipeline. And this is very crucial. I really want you to think about where in the pipeline you want to enforce the policies. And this decision will affect the developers and the DevOps engineers in your organization. So the first option would be to integrate the policies in the CI pipeline. And if you want to enforce those policies in the CI pipeline, we really recommend you to use Conftest, which is also built on top of OPA. So Conftest is an open source library which helps writing tests against any structures filed, XML, JSON, Docker, pretty much anything, and YAML, of course. As I said before, it's built on top of OPA, so all the policies should be written in Rego. And another amazing thing about, really awesome thing about Conftest is that it allows you to push and pull your policies into Docker registries. It's not only about containers anymore. And to use Conftest, really straightforward. You need to download Conftest, write the policies in Rego, and then execute that policy according onto a specific file using the conftest test command. And as you can see here, and you will see the violation output.
It's like unit tests. Feels like unit tests.
Yeah, it's the same. You can really think about it as a unit testing library. And as you can see here, we used GitHub Action just to hook Conftest into our pipeline. We used Docker pull to pull Conftest, and then we ran Conftest test with this path. And pretty much that's it. This is Conftest.
Straightforward. That's the
Yeah,
idea.
very simple. I really like Conftest. As a developer, it made me a lot of sense. But what if we want to integrate our policies in the cluster?
Yeah, so I'm a big believer in shift left, and I believe, like, we as developers, we want to find problems as soon as possible in the pipeline. But then still, sometimes you want to make sure that your runtime is also secure. And I don't know, maybe someone kubectl something to your cluster, or I don't know what. So if you want to make sure that your policies are also enforced and checked on the on the runtime environment on your Kubernetes cluster, you can use Gatekeeper. And Gatekeeper is a great utility, also part of the Open Policy Agent GitHub project, and it uses the admission controller webhook of Kubernetes. And it is much like the operating system webhook. So imagine you're an operating system, there is a process trying to run, then the operating system calls the antivirus and asks him, "Hey, Mr. Antivirus, can this executable run?" And then it tells them yes or no. So it's the same thing. So you kubectl apply a resource to Kubernetes, then this webhook admission controller calls Gatekeeper. Gatekeeper runs a policy check and says, "You cannot push this. It does not have memory limit. Go fix your deployment." And then it rejects the deployment, and then the developer has to fix it. And this way you achieve a runtime protection.
Yeah, Gatekeeper has a lot of other options that you can configure. You can have it on audit mode. You can have it on test mode. It's really, really cool. It's a really cool project.
So how does it work? So you define a constraint template, which then checks for. It says like, okay, for every resource that comes in, that we have a constraint. For example, this talks about labels, and it's very simple. I won't go by line with you, but you say like basically check for metadata tag and see if there is a label, and then some sort of label. Let's say you want to have a cost center, so you want to have a namespace and a label for every resource. And then what happens is that once you apply that, then you write a policy and you send a resource to it, and then you say, okay, this resource and this policy with the constraint, can this be applied to the cluster or should it be rejected? And this is how it works. So it's very, very simple.
Yeah, but it's not the same policy. I mean, if you decide that you want to use both Gatekeeper and Conftest, you will have to write the same policies, almost the same policies. One for Gatekeeper, it
Yeah.
and the cluster will store that those policies, and one for Conftest.
Yeah, so it's both of them are written in Rego. They're almost identical. They're
Yeah.
a bit different. And if it's in Gatekeeper, Gatekeeper will run inside of your Kubernetes cluster, and it will
Yeah.
be there. But you can almost use the same policies.
Yeah, I mean that, but you have it like twice. You have twice two instances of the
Duplication,
same policy.
Yeah.
Okay, amazing. So using Conftest and using Gatekeeper, you can practically protect yourself, protect the entire pipeline.
Totally, totally. So it's great. You integrate it directly within your source control, and you can be protected from dev to production.
Yeah.
So the next step is, how do you control, review, and monitor what you've done? So, for instance, as I said, we're in my previous role. So we had 400 engineers and like 1,000 Git repos. So let's say you define the policy, which is by itself, you need to think like, which policy do we want? Which policies can there be?
Yeah.
And then you need to integrate it into each one of your like builds. But then let's say I want to make a change and I want to introduce a new policy. So what do? I open 1,000 pull requests. So if I'm using raw solutions like Gatekeeper and Conftest, this is exactly what you need to do. If you use solutions like Datree, it comes built in. But just so you know, it is important to be able to dynamically change the policy. It is important, number two, to have full control and visibility into which policies ran on which resource, what was rejected, what was passed, what is your status. So it's sort of like having a command and control solution. And those are the things that don't really come built in with OPA and Gatekeeper and Conftest. And this is what the tree is complementary about. So we come with predefined battle tested rules that you can just use out of the box. You can write custom rules, and you can also have an enterprise grade control and management, so you can oversee everything that happens and dynamically assign other policies, and change them on the fly without having to change the code itself. So how does it work, Noah?
This is really straightforward. All you need to do is to install the tree and execute the tree test on the with the path of the files that you want to test, and the tree will show a full output with guidelines to how to solve every violation and where that violation occurred, as you can see here. And it's free, it's an open source, and since it's my teammates and mine code, I encourage you to submit a pull request, and
And we'll
basically,
try to get to it in time because it's
yeah.
becoming difficult, but we promise we read everything.
Yeah.
Cool. So thank you very much, Noah.
Thank you very much, Iman.
It
Thank
was
you very
great. Thank you,
much.
Conf42. Bye bye.
Bye.